Okay, we're going to look at scatter plots and trend lines, which is really just graphs. We're still looking at graphs except for scatter plots. Instead of having a straight line typically, like we've been looking at linear equations where there's an actual straight line on your graph, it'll be more scattered, hence the name scatter plot, where it just looks like a bunch of dots everywhere. And typically they'll have a trend, like you'll have a bunch of dots either going in the positive manner or in a negative, something like that. But for now, we're just going to look at these to see if they're linear or nonlinear. So the first one, use a scatter plot to answer questions 1 and 2. So the weather conditions are recorded daily. The following scatter plot shows the dew point versus the maximum humidity for a given time period. Okay, so we're looking at the humidity over the dew point, or Fahrenheit. Okay, so we've got points here, 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 here. And so if we look, there's not really a trend. So not a positive trend, not a negative trend. So if the question asks which best describes the association shown in the scatter plot, if something is linear, remember it's a straight line. And so could we draw a straight line through these points anywhere, positive or negative? No. So it's not going to be linear. Increasing, we've got points up here, down here. They're kind of all over the place. It looks like someone just threw a bunch of polka dots on this graph. So we can't tell that it's increasing. If we can't tell if it's increasing, then we can't tell that it's decreasing. So if you see a scatter plot like this, where it literally looks like someone threw a bunch of polka dots on the graph and there's no real trend, then it's nonlinear. You can't draw a line through it. So number 2, based on the scatter plot, which statement is a valid conclusion as the dew point increases? So the dew point, as it goes up, the maximum humidity increases. Not so much true, because we've got maximum humidity up here and then points down here. So that's not really true. G, as the dew point decreases, the maximum humidity increases. Again, there wasn't really a trend or a correlation between the two. H, as the dew point decreases, the maximum humidity increases. So again, there wasn't really a trend. So J, there appears to be no association between the dew point and the maximum humidity. So it's going to be J. Okay, Miss Ellis's nine math classes investigated the link between regular hand washing and the incidence of flu. During the school year, 3 classes agreed to wash their hands 2 times each day. 3 classes agreed to wash their hands 4 times each day, and 3 classes agreed to wash their hands 6 times each day. The data from their investigation is shown in the graph. Okay, so we're looking at the number of cases of flu and the number of daily hand washings. Okay, so the number of cases of flu correlating to the hand washings. How many number of hand washings? That looks like a W. Okay, so if we look at this and I look and see where all of my points are, I've got a point there, 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 there. Can you see what's kind of happening with those points? They're all kind of going downward, right? So the fewer hand washings they have, so if they wash them 2 times a day, the chances of, or the cases of having the flu, 8, 7, and 6, that's a lot. But the more they wash their hands, the fewer cases of the flu that they have. And so when we look at the left side of our graph and our line goes down, remember what kind of a slope or a line that is? It's negative. So looking at my answer choices, positive trend, no, because that would be going up. No trend, that would be like the one we just looked at, and that's not true because there is a trend. Average trend, no, because it's a negative trend. 4, which statement best describes the association in the scatter plot? The association of the data is nonlinear. Well, really, we could draw a fairly straight line through those points. It could make a line. G, the association of the data is linear. Possibly. The association of the data is absolute. The data is not associated. So it is associated because we decided it was decreasing. The number of hand washings increased and the number of flus decreased. So the association is nonlinear. We said we could pretty much draw a line through it. The association of the data is absolute. So not going to be absolute because it's not a perfect little slope line that we have, but it is linear. We could draw a straight line through it. Okay, on the back, we're going to use these graphs to answer the questions that follow. So the scatter plot displays data gathered on the population growth of Jefferson since 2000. So we've got the number of years since 2000, and the years increase, and our population increases. So as the years go on, the population is increasing. And so based on the trend line, which is the best prediction of the population of Jefferson in 2018? So 18 is going to be out here somewhere. So we're going to have to try to predict based on what we have going on here. So looking at your answer choices, A says 43,000 people. So let's look at where it was in the very last year. So in 2014, it was about 40,000. So my answer choice is the first one, 43,000, possibly because it would have to be more than 40. 4,500, no, because that would be way down here. 50,000, that might be too high, or 5,000. 5,000 is going to be way too low. 5,000 would be, again, like right here. So either 43,000 people or 50,000 people. So we need to look at our other options. Okay, so it looks like for every 2 years, so 2 to 4 years, it increases about 5,000 people is what it looks like. About. So if we go from 2014 to 2018, so 2014 there's about 40,000 people. That means in 2016 there would be about 45,000 people, and so then in 2018 there would have to be about 50,000 people. So C. So then on number 2, based on the data, which of the following could be true? Okay, so just remember on that following data, we were thinking in 2018 the population was about 50,000. And it looked like generally the population was going up by 5,000 every 2 years. Okay, just based on that line that we're looking at. So it's going up 5,000 people every 2 years. So the population in Jefferson in 2022 will likely be fewer than 55,000. So if we're going off of that graph in 2020, the population should be about 55,000. So in 2022, it would have to be more than that, not fewer than that. G, the population in Jefferson in 2022 will likely have increased to about 60,000. Possibly, because if I keep adding on to those years in 2022, it should be about 60,000. So that's a maybe. H, the population in Jefferson in 2022 will likely be greater than 65,000. So that shouldn't work. If once we get to 2022, we're at 60, it won't be greater than 65. Or J, the population in Jefferson in 2022 will likely have increased to about 70,000. Again, that's going to be too high because it's going up by 5,000 people every 2 years. So it should be G. Okay, use the graph to answer questions 3 and 4. So we're looking at ice cream sales, and our Y value is the cones sold per day and the temperature in Fahrenheit. So it's increasing. As the temperature increases, the cones per day that are sold is increased. So the more ice cream is sold, the hotter it gets. Which of the following could be true about Carter's ice cream sales? When the temperature is 55 degrees, so somewhere in here, Carter sells about 55 ice cream cones. So about here, and that's where that line falls. That should be between 50 and 100. That should be about 75. So I don't think that's true. I think that's a little too high. When the temperature is below 40 degrees, Carter sells a negative number of ice cream cones. B, when the temperature is below 40 degrees, Carter sells a negative number of ice cream cones. Can you sell a negative number of anything? No. So if she's selling below here, she's not selling anything. If it's below 40, then she may sell 0, but she can't sell a negative number of ice cream cones. C, when the temperature is 65 degrees, so I'm going to use a different color. So when the temperature is 65, so that's about here because that's between 60 and 70, Carter sells more than 150 ice cream cones. So when it's 65, your line at 65 degrees falls about right here. And so that's about at 125 degrees. Or no, 125 ice cream, sorry. So is that more than 150? No. And double check just to make sure D is correct. When the temperature is 90 degrees, right here. So at 90 degrees, our line has cut off. So we don't actually have our line there, but we can use the line we had to kind of predict. So Carter sells about 275 ice cream cones. So let's see if that's right. And it looks like it is, because between 250 and 300, that would be about 275. And so that's right. Number 4, based on the trend line, which is the best prediction of the number of cones sold when the temperature hits 100 degrees. Okay, so based on the last question, if it's 90 degrees and they sell about 275 ice cream cones, then I already can eliminate F and G because those were a little too low. Okay, so if we bump up to 100, based on that, so that's just 10 degrees different. So I think 400 would probably be a little too high, but 330 would probably be good because it's going to be higher than 300, but I don't think it would be all the way up to 400 because your graph over here is going by 50s. So we're going to say 330 cones.